Hello, functions. All right, go ahead and start with this warm-up. I'd like you to state the domain, the range, and tell me whether or not it's a function, and then I want you to tell me why. So go ahead and hit pause and answer those questions. Okay, so remember we want to think about these graphs differently, right? Because this is a discrete graph, and I know that it's discrete because these dots, these points, are not connected, meaning that this graph only represents these points and these points only. And since that is the case, for the domain, we're going to list with curly brackets, ooh, they're really bad, curly brackets, just the x values for these points. So I have -3, let's see, -2, nope, not on 1, not on 0, but 1. We've got 2. And we have, looks like 5. And then we finish it off with curly brackets. So that's the domain. Again, remember, it's just the x values. Now, if I put a bracket with -3 to 5, that means that every value between -3 and 5 is represented in this graph, which is not the case. Only -3, 1 is, -2. So if you see this point is -3, 1. This one's -2, 0. So notice just between these 2 points, only -3 and only -2. Not everything in between -3 and -2 is involved. So then when we talk about the range, again, because this is discrete, we're going to have those curly brackets. And I'm going to find my smallest possible y value, which is -5. And then I go all the way up till 0. And then it looks like 1 is here and here. So since I see it twice, I only need to write it once, since I already represented it. And then up to 4. Oops, there's a comma between that. And then do a curly bracket. So then the last thing is, so I've done domain, range. I need to know whether or not it's a function. So if I go and do a vertical line test between these points, I don't hit another point, I don't hit another point, I don't hit another point. So yes, this is a function. It passes the vertical line test. I'm going to do the same thing with this one. So my domain looks like this is -6. So -1, -2, -3, -4, -5, -6. So my domain is going to start at -6, which is my smallest possible value. Now the dots are connected, so I can use that interval notation, register notation with the curly brackets. When it's discrete, this is continuous. So I'm going to go all the way, and then I'm going to go to 1, 2, 3, 4, 5, looks like to +6. But there's that hole in the graph, so I'm going to use a parenthesis. And then for that's my domain. Then for the range, it looks like the smallest possible y value is 0. And the largest is +6, I think. 1, 2, 3, 4, 5, 6, yep. And those are both included. So I'm going to go ahead and include those. So there's my domain, there's my range. Now, does this pass the vertical line test? Yes, it does. So yes, this is a function, and it passes the VLT. Okay, so if you have any questions on that, or if you weren't sure about how to do the register notation, please ask those questions in class, but hopefully this cleared that up. Okay, so when we're going through something like this, this is saying find f of 4 for each function. So this question says, when my input, so this number inside of here, that is your input. So when my input is 4, what is my output? Okay, so that's what we're talking about. So x is our input, f of x or y's are output. So when I'm looking at this, this is saying for this function right here, this graph, for this input 4, so my input 4 is right here. There's your input. My output, whoops, my arrow got weird. This is my output. So then for f of 4 for this function would be 16. So when my input is 4, my output is 16. So when we're looking at this, this is a discrete graph with just points. My input is my x value, so when my input is 4, input, then my output is going to be the y next to it, my output. So for this one, for b, for f of 4, then my output would be 2. So that's what it's saying. When my input is 4, my output is 2, or my answer. Same for this one. So now we're going to rewrite this. So f of 4, and everywhere I see an x, I'm going to replace it. So that's with the parentheses, the 4, and then I'm going to finish the function. So I get that when my input is 4, then my answer is negative 16. Because 4 times 4 is 16, times negative 1, which is negative 16. And then this one is the same thing. This is my f of x. So when my function, so I got to find on the graph when my x is 4, my input is 4. So there's that point. So I've got 4, and my y is 5. So for this one, when f of 4, when my input is 4, my answer, my y, is 5. So that is 1, 2, 3, 4 different ways to represent a function and 4 different ways to find an input. Given an input, what is my output? That is what it's asking you. When my input is this number or this letter, what is my output? So that's what we're doing for all of this. So I want you to go ahead and hit pause, and I'd like you to evaluate these. Okay, so now we're going to do this. So I did the first one. I went ahead and did when my input is 0, what is my output? So when my input is 0, my output would be, so I would put 0 in, and because it goes, the square goes with everything inside of there, so 0 times 0 is 0. So I get 3 times 0 minus 4. 0 times 3 is 0, so 0 minus 4. So then my output is negative 4. I'm going to do the same thing for this one. So I'm going to do negative 3 times 1 squared minus 4, because this is my f function and I'm finding my different outputs. So when x is 1, my y is going to be negative 3 times 1 minus 4, which is equal to negative 7. Do the same thing here. Negative 3 times negative 1 squared minus 4 is going to be equal to negative 3 times positive 1 minus 4, which is still negative 7. And then when my f, or my input is 2, I'm going to get negative 3 times 2 squared minus 4, which is 3 times 4 minus 4, which is 12 minus 4, which is 8. So make sure that's the way that you have done that. Make sure that it makes sense to you. If you have any questions, please ask me. I would love to answer them. All right, go ahead and get these examples in your note. Make sure that you copy down this function, f of x, and then I want you to do all of these. So I will do the first one with you. So we are going to find f of a. So that means everywhere, oops, I didn't need to write that again. So everywhere I see an x, I'm going to replace it with an a, and I end up with 3 times a squared plus 1. And then that is my final answer. So then if we are doing the next one, we're going to do the exact same thing. So everywhere I see that x, I'm going to replace it with the parentheses, the 3a. So 3 times 3a squared plus 1. Well, when I have something with a coefficient and a variable, I actually end up with 3a squared is really equal to 3a times 3a plus 1. That will help me to remember that I need to multiply those coefficients. I have to square everything that's inside of here. So that's what this is showing. So then I end up with 3 times 3 times 3 is 9. A times A is A squared plus 1. And then I end up with 3 times 9A squared, which is equal to 27A squared plus 1. Okay, so now we have a binomial as my input. So an input, like I said, so these two questions are good examples of a progressing level question. My number 3 is a binomial. This is a really good example of a meeting level question. So if I were to put this in as my input, that means everywhere I see an x, I'm going to replace it. So I'm going to do 3, my x is right there, so times x minus 5 squared, and then I have plus 1. Well, again, just as a reminder, my squared means that that binomial is being multiplied twice. So I'm really looking at 3 times x minus 5 times x minus 5 plus 1. So when I multiply a binomial, you can choose 2 different ways to do it. You could put it in a box. I'm going to do it over here. I might not have enough space. And then we do x minus 5. I'm going to do it over here. X minus 5. I know normally we do it right here, but I just don't have the space. So x times x is x squared. Negative 5 times x is negative 5x. Negative 5 times x is negative 5x. And then negative 5 times negative 5 is a positive 25. So if we do that, then we end up with, combining our like terms, we have 3 times x squared minus 10x plus 25 plus 1. So then we need to distribute that 3 in front of it to all the things that's in front, to everything. So we end up with equals 3x squared minus 30x plus 75 plus 1. Then we combine our like terms, and we end up with 3x squared minus 30, oops, tough time writing, 30x plus 71 plus 75 is 76. That's a 76. Okay, so here's a really good example of a transfer problem. I just showed you how to multiply a binomial as an input. Now I want you to try 4 and 5 on your own. Hit pause, see if you can do it, because this would be a really good example of a transfer problem. So try this. Okay, so you should have gotten 3a squared plus 6ab plus 3b squared plus 1. I combined all my like terms, and that's what I finished with. So you should get the same thing for 5. If you're not sure, you can show me your notes in class, and I'll let you know if you got 5 right. But if you have any questions, please let me know. Otherwise, make sure you get your homework done. Part 1 and Part 2 are both due on Wednesday. So go ahead and finish those up. If you have questions, please come to class. Come before school or after school and ask me questions. Otherwise, I hope you have a great day. Thanks.